n， 然后 x 小于一个 epsilon 嘛。这是如果是这个叙述的话，那我们要怎么串起来这两个条件？因为我其实那时候就是三角不等式这边看不太懂而已。
三角不等式这边看不太懂，好，
主要是这个就是这个 n， 然后这个 subsequence， 我不太知道要怎么把 subsequence 跟另外一个串起来，因为我不太知道我们可以直接令它收敛到 x 吗？
可以直接令它收敛到 x 吗？先令它收敛到 x， 我想写解答的时候是直接写说它就收敛到 x 了，对不对？好，subsequence that converge to好，我先上课，你让我想一下，看要怎么讲这个东西。Okay, so continue. Random variable and distributions. So the definition of a random variable is a real valued outcome there, and a functions from the simple space to the real line R. Okay, so for example, like if you consider a coin flip here, the outcome could be head or tail. Okay, but if you put it that way, then the x is not a random variable. You have to transform it into a real number. Okay, so put it this way, the x becomes a random variable. Says that if the outcome is h, which is head, then x equals 1. If the outcome is tail, then x equals 0 here. And of course, like this is for the discrete type of random variable. And we can also have the continuous type. For example, like here, this is a uniform distribution from 0, 1. Okay, and you can simply put this x as the random draw that you draw from the 0, 1 distribution, uniform distribution, and not defined otherwise. OW means otherwise. Okay. And from now on, you are going to have a lot of notation, so you'll be better to have some good practice here. So here, the convention is to use the uppercase to denote the random variable, which means the real, how to say it? The outcome is not realized yet. So you don't know what this uppercase big S is. And once the outcome is realized, so you put it as a lowercase small x over there. Okay. And then is the CDF, cumulative distributions functions. Okay. So what does that mean? From the definitions, it's a function f of small x that all the probability big S smaller or equals x. So this is the event we are interested in. And the big F, the function big F here, is just the probability of that event happens. Okay, so it looks like this one. It's a non-decreasing function of x, okay, and it starts from 0. Meaning that if you push x to minus infinity, for example, like here, okay, so it's still 0. Okay, and to some point it will start to increase because the event is well defined, and when it goes to plus infinity, so it's capped. So maximum 1 here. Okay. And non-decreasing meaning that for some point it could be flat. Some interval, for example, this could be flat. Okay, but it's not decreasing. Okay. And final bullet point is right continuous. What does that mean? That means it could have some jump. Let's say here, x naught. Okay, it has a jump here. Okay, so it's continuous from the right, but it's not from the left. Okay, so because there's a hole over there, and the reason that it's right continuous is because the way we define it here. Okay, it's small equals. If we define it as the strictly smaller than small x, then it's left continuous. You can verify it by yourself. It's not really important, but just put it there as a side note. Okay, then usually we'll write it this way. So x wave side of f, meaning that this random variable x is from that distribution f. Okay, here the random variable x is distributed as f. Okay. And another related concept or related function is probability distribution function, PDF here. Okay, so if this big F is differentiable, okay, then we can actually know what is the probability of a certain event to happen. For example, like back to continuous here. For example, like I want to know the probability of 0, x0. So this is exactly the differentiation, first order differentiative at the point x0. Okay, and of course, if we want to note a certain interval, how to say that? If the event is a certain interval, then we can also calculate it as well. So let's say that we want to know what is the probability between x0 and x1. Okay. So from the graph, you can see this is actually the whole probability from let's put it 0 as well. From 0 to x1 minus 0 to x0, right? Minus this part. So we can write it as f x1 minus f x0. And of course, if you are familiar with calculus, you can write it as this way. That is the integers from x0 to x1, then f of x dx, right?